Actually, Dennis was going to introduce me, but I think I have a few words of introduction to let people know who I am or how I got involved with drones. In particular for doing mapping. Fundamentally, as we all know, drones are now pretty commonplace for doing photogrammetry and LiDAR, and which are in fact geophysical tools, although most people wouldn't describe them that way. There are also geoscience data sets that we integrate with our geophysical data. I began, back to my thing, became interested in drones in around 2014. And the reason I did is I realized as I was driving back to Denver, where I'm based, from Nevada, that I was doing a same survey that you would have done in the 1960s, walking across the desert, collecting VLF-EM data. I thought there had to be a better way. And that when I got back to Denver, I started investigating it, and I started attending various local meetups of people that were beginning to get into the business. And I realized that this was a business that had really good growth potential. So my background is I've been in geophysics since 1976, and I've done a lot of different things, mineral exploration, environmental work. I won't go into that too much, but the title of my talk is The Elegance of Drone Geoscience. And the more I thought about it, the more I've realized how elegant it is to be able to acquire data using an unmanned aerial vehicle or an unoccupied aerial vehicle. And hopefully today, what I'm going to do is actually start kind of generating some thoughts and some discussions by reviewing a little bit about the work that I've done and some of the work that I think I see coming. So this is my sort of talking points. I'm going to start off with looking at sensors, and I'm going to look at some 10 applications, benefits, and factors impacting drone mapping, drone surveys for ground versus ground surveys, and then go through some of the examples that I can show, and then summary. And what I'm going to try to do is go through all of this pretty quickly so I can get to the what's next, because I think what's next coming in the drone world is really the exciting part. So first off, let's review the methodologies that we actually apply, the sensor types. See if I can get this to work right. There we go. There's a line there, a demarcation line. That's the actual surface of the Earth. Everything above is really referred to as remote sensing, with the exception of gamma ray spectrometry. Everything below is really referred to as geophysics. And I'm not going to talk about seismic and gravity, but there are folks working in the world of trying to do that. I'm really going to talk about magnetics and a few electromagnetics. I'm not going to talk a lot about GPR. The next speaker is an expert in that. He's going to review that. And I'm going to talk a little bit about gamma ray. All the stuff above that is handled by other conferences, other speakers and stuff. But all of that data is actually very much integratable with what we're doing in terms of geophysical mapping and whatever the application is. So when you think about I thought of let's talk about the top 10 geoscientific applications. Well, there's no top 10, there's just a lot. So I thought, well, let's talk about just 10. And the first is the surface mapping of features of interest, topographic mapping, surface mapping of rock type, structure and alteration, subsurface mapping of rock type, structure, alteration, groundwater, detection and delineation of geohazards, detection and delineation of contamination, detection and delineation of things that go boom, unexploded ordnance, characterization, assessment of infrastructure, monitoring natural and extractive processes. I'm not going to dwell on that or talk about it a lot, but one of the real benefits of drones is that you can do a survey and you can go back and do it again. And you can do it again. That means you've got not only spatial mapping, but you got temporal mapping. and detection of gaseous emissions. Benefits, I won't go through all of that. I think a lot of us are here because we understand, or at least in our own work, what the benefits are. Probably the one that I get asked to do mostly for doing drone work is accessing difficult areas. But I'm very much involved with ultra low altitude surveys. I'll go into that a little bit later. And I'm very much into improved spatial data density. Bring the sensor closer to the ground, you get enhanced signal strength. You got lower operational costs. That's a large part what's driving the use of drones in the world. Improve safety to field staff, reduce risk to property and property damage, facilitates temporal change detection, and in my case, I really can quickly turn around the data products. These are all factors that are, the top one are limitations to using drones. I won't go through that. I just want to point out that weather is one of the most significant limitations to using a drone. And then the bottom thing is a list of restrictions. Probably the biggest restriction we have right now is the fact that on most of the world we're using, we have a limitation in payload or the size of the drones we can use to 25 kg. Everything else, all of those things are in the US, at least you can get variances on flying them. In the future, some of those restrictions will just go away. And I'll tell you why in a minute. Now, this is actually one of the first surveys I ever did with a drone. It was a magnetometer. It's called the Mag Arrow. It's made by a company in California. I did a ground survey after we flew the drone survey. The drone survey took an hour. The ground survey took 4 hours. And what I have here is that's the ground data inset on top. This is raw data. This is not data that I've processed to any extent. And I was so impressed with it. That was what we were mapping, this thing called the Crestone Crater. The Crestone Crater was hypothesized to be a meteor impact crater. We don't believe it is today, but I think it has another explanation for it. But that's the magnetic signature on the ground. The one from the drone is very similar. So that's what told me that we were onto something. It wasn't so much that we were advancing the science, because the magnetometry was pretty common. But what we were doing is improving our ability and our efficiency to collect the data, which meant in long term, we could actually collect a lot more data for the same amount of money. The second thing that I wanted to emphasize early on is that drone surveys are very scalable. This is the same area. This survey is about 2 3/4 square miles. That's about 600 by 600 meters. And there we have basically probably 100 meter by 100 meter survey. So you might, for example, one scenario is you might actually fly a bigger area, identify a target area that you're interested in, although it's not really seen in this data set because we have too wide a line spacing. Then you come in and do a very detailed survey, and then you narrow it down and do an even more detailed survey. From whatever your application is, that gives you a lot of latitude in collecting data types that are specific for the targeting or whatever you're trying to answer is your problem, your geologic or your infrastructure or your engineering problem. So what I've done is I've broken out the world of drone data collection to 3 airspace. The first one is in the US and most of the world, we're limited about 400 feet above ground level without having to go get a variance and what in the US is called a waiver that allows us to fly above 400 feet. Turns out I really don't want to fly at above 400 feet. I really want to fly as close to the ground as possible. But I have trees well, occasionally in Colorado, we don't have many trees, but we have a few trees where I have to fly above the trees. So from the tops of the trees to the regulatory limit, I call that standard air altitude. From the tops of the trees to about 5 meters, I call that low altitude. And we try to get it as low as we possibly can. And then from about 5 meters to ½ a meter above the ground surface, I call that ultra low altitude airspace. And the reason that I'm distinguishing that is because each of those airspaces offers or provides opportunities for operational changes. When you're in normal altitude, you're not worried. You're worried about aircraft. You're worried about things like that. When you're in low altitude, you're definitely worried about things like trees or other stuff and aircraft. And then when you're in ultra low altitude, now you're worried about not only the vertical structures, but you're worrying about being able to see your aircraft or maintain radio communications with your aircraft if you have any sort of topography you have to work with. Plus, you need to worry about things you might fly into. So what I've been working with is, and I'm kind of coming from my experience, and what you'll find for the rest of this workshop is there others have experiences that are really kind of very valuable in us trying to apply drones and various geophysical sensors, and ultimately geophysical and geoscience sensors, things like LiDAR and photogrammetry and multi-spec stuff, to mapping the surface and the subsurface. The ones I've been working with, most experienced with, is the MAG Arrow, and this is the current configuration, close to the configuration I'm flying. That's the sensor package there. I can certainly elaborate on what that really means in terms of why it's a really nice, innovative sensor package. Then recently, I've been working with a time domain EM system called the Geoscience EM61 Lite. That's a coil, and it's actually pulsing the Earth with a time domain signal, and it's meant to actually detect metal. And then I've also been working with a frequency domain system that is mapping conductivity variations. And if you notice here, we're working with a suspension system. The whole point of this is that it actually helps stabilize the sensor as we pass it over the Earth. What you might see here is we have a radar altimeter on our drone that keeps the altitude of the drone at proper altitude as it passes over the Earth. And then we've been recently working with a gamma ray spectrometer. I'm going to show a little data mostly from the MAG Arrow, a little bit from the EM61, and a little bit from the spectrometer. We're in the process of really building the workflow and actually building the data processing, the whole thing. But these are the four that I think have great utility within the use on a drone, and whether it's resource exploration or whether it's infrastructure mapping or whatever, these have very much a broad set of applications. So now the other thing that I put together is what our depth of investigation is. I can't tell you how many times I get asked, what's the depth of investigation of a magnetometer survey? Well, it really hasn't changed, you know. We just happen to be more efficient in acquiring the data. Anywhere from a few centimeters to thousands of meters it's a scalable thing. EM, I won't talk about GPR. There are folks in the world that are flying a GPR. We have some legislative problems in the US, so I'm not really focused on that. But the conductivity and the metal detectors. And then at the bottom here, I have semi-airborne EM. And Dennis is, I've been watching learned a little bit more about his system yesterday. In a sense, that's a semi-airborne EM system. So I hope that you'll visit with him on it a little later during the conference. I won't go through a lot of this. These are kind of the MAG Arrow projects that we've been working with. Yes, I do mineral exploration, but a lot of what I've been doing is really working on things that are much closer and much to the surface, and really looking at infrastructure type problems these days. So this is a sample data set over a mineral exploration project I did in Colorado. This is probably 3 or 4 years ago. We've worked on mine sites in Nevada. Actually, this mine is in California, but that's kind of an example there. This was a project where we were mapping geology for a dam site investigation. And I won't go into the geology part of it, just an example. This is the landfill subsurface characterization. This happens to be one of our test sites that we started working with, and we go back to it all the time just because we know we can get a good mag response. and we'll get some good EM response. This is results of a project we did last October, where we were tasked with locating some buried pipelines that had not been documented. And you can see that we have a lot of linear features on here from the magnetic data, which is resulting from the pipelines. But we're also seeing the oil wells too. And then we got the opportunity to test a gamma ray spectrometer called the D230A, and this is some basic results from our first flight of that. We expect that later this year we're going to actually be doing more work with this just to verify and understand how to actually deploy this particular system. So, and this is where data from EM61 over a pipeline. I have a great example where you actually discovered the pipeline when we were locating an oil and gas well, and it become one I could go out there and I could fly. It's pretty close to where my office is. So, see here. This is channel 1, channel 2. That's a little bit less in time. Channel 3 is actually diminishing, and by the time we get to channel 4, the response to the pipeline goes away. We have a great deal of we think this is a good technique that's going to be applied to a lot of things, not resource exploration specifically, but it really more infrastructure mapping. So the summary, basically the UAV magnetometry is pretty well established. In fact, it is well established for subsurface geologic mapping for resource exploration, and is increasingly being used to detect and map buried objects like the pipelines. EM61 light is applicable to detecting and delineating highly conductive objects within the subsurface, things like unexploded ordnance, pipelines, stuff like that. The GEM2, the reason I'm not showing GEM2 data is that I'm still working on getting that stuff sorted out. I do have a bunch of data, I just didn't want to throw it there. But those are starting to, that systems are starting to come to fruition. We're learning how to fly them and keep them stable, meaning that we're also learning how to reduce the amount of noise that might be in the data. And then all of these tools can be combined with commonly used mapping methods such as photogrammetry, LiDAR, spectral imaging, things like that. And the result is a cost-effective data volume providing information about the subsurface, surface and subsurface. Now, the thing that I really want to talk about to you today is what's coming. What's coming is beyond visual line of sight. That means that we can put a drone up and we can fly it without actually the pilot maintaining visual line of sight with the aircraft. That means we can fly bigger areas. That means that we can also start looking at getting larger aircraft, because once you can fly beyond visual line of sight, you now have you're in complete communication with the drone at all time. You know where it's at, and that leads to actually flying. The third item is that although there is some fixed wing aircraft out there, we're going to see more fixed wing aircraft VTOLs with sensors embedded in them. We're going to see larger aircraft that capable of heavier payloads. That's one of the biggest restrictions we have right now, is the payload capacity of the current crop of aircraft. And then we're going to see purpose-built aircraft. We're going to see things that are really built around what the sensor is actually mapping or collecting, and not necessarily what the drone is. Meaning, what I mean is that there are going to be innovators that are going to bring out aircraft that are really focused on the purpose of the mapping. And that also means we need more EM sensors. EM is, most of those methods that we're using today is one form or another of an EM method. But there are those that are also working with gravity, building innovative lightweight gravity sensors can be used with drones. I actually, 2016, I interacted with a graduate student at School of Mines in the Geophysics department, and he was applying it to mapping seismic movement of the earth. Turns out that he was hired by a company called ExxonMobil, and all of his graduate work for his PhD disappeared. So they're now kind of pushing within the bowels of a large corporation. They're using drones or exploring the opportunity to use drones for seismic work. And then the thing that I'm really focused on too, which I think a lot of those that are in the business now realize we need to work on this, is we need to have, at the level of the sensor, we need to have detection and avoidance technology integrated with our drones, just so we don't hit things. Then what I predict is we're going to see a bunch of innovative thinking in terms of sensor technology, sensors that we hadn't really thought of before. And we're going to start really seeing that. The reason for that is that this is the whole business of being restricted, flying 25 kilogram maximum payloads, is that it's allowed us, it's given us the impetus as an industry to actually start rethinking how we actually make these measurements and what we're using to make these measurements. And that innovation is really what's going to drive our industry. Now, we're going to see multiple sensors and multiple data types on drones. I allude to that. I drone on about that. That's really where we're going. And then what we're also going to see is near real-time data processing and analysis of the data that we're collecting. In fact, there are those that I'm aware of that are actually trying to put that on board of the drone. So as they're acquiring the data, they're trying to do the analytics of the data. So by the time that the whole goal is, by the time of that drone lands from its mission, it's got an analytical product that can be then driving whatever the objective is for that survey. So I thank you for your attention. As I indicated, I tend to drone on. I will take questions if you have any, if we have enough time. Oh, well, that's unusual for me. I usually go over. So does anybody have a question they want to throw at me? Yeah. Okay, what I showed there was an example from the very first time I flew the drone. Once I had sorted out how to actually acquire it. And then I went and I had a team come in and a company out of the Denver area, they flew the drone. It was a prototype version of the Mag Arrow. And once they were done and left, I went out and I collected the data to actually build a comparative data set with which I could verify what the drone data were telling me. I don't do that as a normal thing. And I don't get asked to do ground surveys. I get asked to do, at least I don't get asked to do ground surveys when I can do a drone mag survey. However, there are times I'll do a ground survey when the weather impedes my ability to actually collect data on the ground, in the air.
We got the hand mic working now, I think. Are we on, Dom? Yes, we are. I got a question in the back here.
Hey, Ron, that was very interesting. Thank you. You mentioned about BV loss and your kind of excitement at being able to fly beyond visual line of sight.
Would you kind of take off your mask and
Sure. How many additional operations do you think that will give you in terms of, you know, the capability to do that? Will it double the amount of things you can do, or triple, or just will it give you a few extra type of operations you can run?
I'm not sure how to answer that question.
It's an interesting question.
Yeah, it's an interesting question. So, is anybody else in the audience who's a drone service provider would be willing to answer it? I can't predict that. I know that
I think we're too early to predict that.
Yeah, I think so.
I don't know where it's going to go. It could be 90%, or it could be 10%. I don't know. That's a very good question. I think that's maybe one of the things we try to answer in the next couple of days.
Yeah.
We are going to have a speaker talking about beyond line of sight, the specialist in this sort of area. Maybe he can answer it. He's a virtual speaker from Calgary, so we'll hear from him later this afternoon.
All right.
Any other questions?
We have a question from Jerry Roth. Jerry, would you like to ask directly? I'll unmute you. Okay, well, if
yeah, no, here I am. Yeah, great talk, Ron. I just was curious on the radiometric plot. Where was the survey flown? And I didn't really get a sense of scale.
I'm not sure I fully understand the question. What?
Which particular survey are you talking about, Jerry?
The radiometric.
Oh, that survey
You
was.
did a
That survey was flown over a uranium mine in the Front Range of Colorado. It was, they're actually doing a remedial action on that mine currently, and I got permission to fly over the dumps of it. The census scale is, it's probably that survey is probably a half a mile long actually it's probably a mile long by a half a mile wide. It's in the actual terrain is very steep on each side of that. And that was the first survey that I flew. I flew it at 40 meters above ground level because there was a lot of power lines and stuff over the leading into the facility, and I didn't want to have an incident, so I flew it a little higher than I would have. What I plan to do, Jerry, is that this summer I plan to fly over some sites in western Colorado, which is in the Uravan mineral belt, which is a historically active uranium district. And the idea there is that I'm hoping to calibrate the data that I'm able to acquire with the D238.
That data you showed is you were expecting more of a uranium response there? It's an old uranium deposit.
To be honest, I didn't know what to expect from that site.
The data, excuse me for saying, looks pretty random.
Yeah, I was just flying it, and I was surprised to see that I actually got as well as I could. I think we flew it too fast. I think we needed to fly it lower. I actually did fly it lower, but I didn't do it on a survey program. I just manually flew it. I wasn't particularly happy with those results. It also pointed out the need to have a terrain following technology with my drone. I didn't have it on the drone at the time. I have since now upgraded my drone to have that. And the whole idea is that I'm going to go back and find a site that has got some science, been studied, and I've got data that can reference.
That'd be good. And I think we also have Radiation Solutions might be having some case studies here.
Yeah, yeah. Radiometrics is on the surface, because you can bring it closer to the ground, it has some advantages. Because you can fly it slower, it has some advantages. But we haven't really worked out the process of the data collection yet.
Right. Any other questions?
Thanks, Ron.
Yeah, you're welcome, Jerry.
Hi, Ron. I'm really curious to know, kind of using the earlier metaphor, which newborn emerging out of the technology are you most excited about and why?
Oh, boy.
I know it's a big question, but I'll challenge you there.
You know, what I think is in the course of the next year, the magnetometry is pretty well established, and we're going to see some very interesting applications. I've been applying it to looking for pipelines. What that really translates to is where is the market for it? And so that's, in a sense, it's not quite a newborn yet. It's probably a 5-year-old, but the mag and the infrastructure mapping is going to increase significantly. The mag in the EM61 light, I have great belief that it's going to actually see a number of applications, not just unexploded ordnance, the pipelines, because what we're doing is we're actually energizing the subsurface. Now, what I really want to see is a time-domain EM system that gives me proper mapping of geology. And I do think that is coming, but I think currently with the technology the way it is, we need to have a heavier lift drone. And that is the exciting part of the beyond visual line of sight legislation. Once we get that in place where we've got it sorted out, we can actually fly beyond visual line of sight. And there's another complications with that. We're going to see systems like you see currently on a helicopter-based platform. We're going to see that transferred to a drone-based platform because we'll have a bigger platform to work with. So that's the newborn that I see that's really coming for geologic mapping, is being able to use a bigger platform with very interesting sort of geophysical systems.
Yeah, I think there's 3 factors that go into that, answering that question. One is technology, just what technology is going to come along and new sensors and things. The other is the legal framework. What can we do? And the third is the market,
Yeah.
who's willing to pay for these surveys and how much are they willing to pay? And I think those things have to sort of balance each other out and grow together. And I think that's the way it's going to go forward.
I totally agree. Anyway,
Okay.
thank you very much for the opportunity to share with you my experience and my thoughts about the future for drones. I think that, as Dennis said, we're maybe early teenagers right now in some areas, and that we've got to guide it properly. But this is an expanding technology, and it's sort of expanding in a number of applications, meaning that there's going to be money available for those of us that are in the business to actually continue to do the work we do. And the elegance of drone geoscience, if you read my abstract, I got to tell you, every time I see the drone goes up in the air and flies back and forth, I got to think, wow, how beautiful is that? How elegant that is. And I'll leave you on that note. So